Welcome to a wide-in quick chat from the Initiative in Computational Humanities, Arts and Social Sciences through the Faculty of Computing and Data Sciences at Boston University. Today we will hear from Neha Gondal, Assistant Professor in the Sociology Department and the Faculty of Computing and Data Sciences, who will introduce social network analysis. Her primary research interests lie in exploring the relationship between social networks and culture and its role in the production and maintenance of social inequalities. She employs cutting-edge statistical techniques for modelling social networks, including varieties of exponential random graph models and agent-based models. She uses these techniques to study diverse contexts, such as elite consolidation through money-lending ties in Renaissance Florence, inequalities in academic communities evident in citation and hiring networks, and the clustering of unhealthy outcomes in Boston's public housing developments. Please welcome Professor Gondal.
Thanks, Wesley. So today we're talking about social network analysis, and this short talk is pitched at an extremely introductory level. My assumption is that you don't know what social networks are, and my hope is that you'll be intrigued by social networks by the end of this talk and maybe encouraged to use social network analysis a little bit in your own work. So let's begin, so there's a tendency to think of social network analysis as a methodology. So my goal today is, yes, to talk a little bit about the methodology of social networks, but really social network analysis is a theoretical perspective, which has a suite of methodological techniques that go with it. But really that's secondary to the theoretical epistemological position that relationality matters for explaining human behavior, and that relationality in itself is a measure of human behavior. That if we're used to thinking of things we do, the way we think as individual decisions, so who I vote for is something I think about, I engage with the political climate, with candidates and so on, and I make a decision. But really a social network or a relational approach to this problem delves into who you talk to, who are your friends, who are your family members, to try to get a better sense, of how the people we're connected to affect the way we think and what we do. So broadly speaking, social networks are aggregations of things that we call connections, or alternatively called ties, sometimes also called edges or other affine kinds of terms, between things. So the two key words are connections or ties between things. So I'm going to give you some examples of how of the kinds of social networks that we can typically analyze. So the first kind of thing that comes to mind is persons. People are connected to each other in a variety of different ways, and these can be connections of social support, friendship, sexual ties, etc. Anything that you can think of. And so when I typically say social networks, people think I study Facebook or Twitter. I've actually never studied Facebook or Twitter or any of these other social media sites. That's sort of a separate kettle of fish. Social networks, most often people who study social networks measure ties between organizations, often in real world kinds of situations rather than in virtual reality. Another kind of thing that connects is organizations. Here you can think of academic institutions, private sector corporations, companies that produce things, academic institutions tend to be connected to each other through hiring of graduate students, for example, or through shared grants. Companies tend to be interconnected through production relations, through financial ties, for example. Anytime you can think of a thing, the creative part of social network analysis, actually the crux, which I'll come back to in a later slide, is to think about how things are connected to each other. And this tends to be the most challenging often, to imagine, okay, we have a set of things now, how exactly are they connected to each other? If you can sort of cross that barrier, then social network analysis becomes much more accessible as a way of thinking and doing social science. Similarly, we can think of countries where we can think of trade ties, and this is something that has very often been analyzed. Anything that, for example, gets into world systems theory, for example, or diplomatic relationships between countries, or which country exports what from whom. These are all ways in which we can think of social networks because we're thinking of entities that are connected to each other. I can give other examples like documents, papers, and many, many other kinds of things, but I'm going to go a little forward so you can get a flavor of what social networks, how we end up finding social networks. So typically, social network analysis data are gathered through observation. This could literally be, for example, if you're interested in studying interactions between young children, you could sit in a playground and observe who's playing with whom, who's bullying whom, who's being nice to whom. Those are all ways in which children could be connected to each other. Right? Another way typically is through interviews, and we're doing this kind of thing right now in Boston's public housing developments where we're asking people things like, so who do you reach out to for social support? Who do you do groceries with? Right? In order to find out who the close personal relationships are of people living in these contexts and how that affects their health outcomes. Archival records. Very often, networks are created or made, and I use this word, network data are constructed. Most often, and I'll come back to this last point, publicly available sources manipulated to look like networks. I don't use the term manipulated lightly because social network data often have to be constructed, created from things that don't ordinarily look like networks. When I go and interview people in Boston's public housing, well, somebody interviews them, and I create that instrument that helps me know more about their relationships, I know I'm collecting social network data. When I ask adolescents in high school, and it's a very well-known social network data set called AdHealth, where they collected data about adolescents' friendships and sexual interactions and other kinds of things in a variety of high school settings across the United States, we know we're looking for network data. But very often, the art of social network analysis is to render a problem that we don't necessarily think of in network terms as a social network. And I'll come back to this in a few slides. But first, let's say we go and we start collecting data, and these A, B, C, D can be anything. It could be human beings, it could be organizations, it could be countries. And the ties could accordingly be, for example, trade relations or social support ties. Fill in the blanks with whatever it is that you're interested in investigating. It might start by looking like this. This doesn't look like much. A is connected to B, C to D, and so on. They're like disconnected. It seems sort of meaningless at the moment. But as you collect more data, things like this start to emerge. Some structure starts to emerge as you collect more data. And eventually, you get networks that look something like this. This is a small sort of a snapshot, a toy example of what social networks might look like. And here immediately you can see this is very different from where we started. Nothing, there's not much of interest here, but this seems much more interesting. Why is that? We can immediately see I, for example, tends to be at the center, tends to occupy perhaps a position of influence or power because I is better connected, more popular than any of the other nodes. That's the other way of thinking about these things, nodes in the network. We can also start seeing sort of instances of structure. We can see squares. A, B, C, and D are connected in a square. These are potentially two couples who know two other couples, so there are friendship relations across them. That's one way of thinking about it. Another way of thinking about it, if these are countries, you can say that A and B are connected to each other through diplomatic ties, A and C, C and D, and so are B and D, but B and C don't have diplomatic ties. And we can imagine that going forward, given that A, C, B, and D are connected to each other, there might emerge a diplomatic tie between B and C. This might be a kind of investigation I want to pursue using social network analysis. Other kinds of structures such as triads, E, F, and J, and G, H, and I are implicated in triads. And these different kinds of structures have different kinds of meanings. They can be indicative of differential power. They can be indicative of, if we, for example, add attributes to them. We color the nodes now, and each of these different colors might be, let's say, ethnicity or racial ethnic categories, and we can see, maybe we might start seeing signs of what we call homophily in social networks, which is the idea that people or organizations or whatever it is, entities tend to be connected to others that are similar to themselves. So homophily, when it comes to human beings, suggests or shows that people tend to be friends with others who are like themselves. And in the case of the United States, for example, there is tremendous homophily around race. Data suggests that nearly 8 out of 10 of our ties tend to be race homophilous. So if you look around your network, see who you're friends with, who your relatives are, more likely than not, they're going to be people who look like you in terms of racial ethnic categories. We can add additional parameters. The shape now represents a second attribute, which could be, say, age or gender or something else. And now we can see that we can look for the simultaneous operation of structure as well as attributes in the way social networks are formed. Okay? This was a toy example. When you put all this together, often you get social networks that end up looking like this. Now, this sort of looks like a hodgepodge, there doesn't seem to be much here, right? But actually there is. This is a network that I've studied. Anybody want to guess what this might be? Or that's too difficult. Anyone want to maybe say something about this network? Can you see something when you look at this? Yeah.
I don't want to bring COVID up, but it kind of looks like maybe transmission of viral diseases with like different colors.
So it could be transmission of viral diseases. You could have the red nodes that are potentially infected nodes, and those could be spreading the virus outwards. That's a good guess. This is actually lending ties from Renaissance Florence. These are 14th century Florentines, or each dot is one Florentine who lived in the 14th century, and the ties between them is who lends money to whom. And the way we coded these ties is literally the account books from 14th century Florence, double entry bookkeeping, which says, I lent money to this person, and there's a little narrative often that accompanies that, which shows, oh, this is what this, this money was for this purpose. This person is my nephew who was desperately in need for money because he couldn't meet his tax obligations. Yes, you have a question.
So are the positions of the nodes like arbitrary, or how are you assigning?
Okay, good. So that's a good question. So I'm using a software called Payek here, which is Slovenian for spider. And this software, and typically network visualization softwares use certain algorithms. One that's used very often is one that places, called Kamarikawai. It places nodes together if they're connected to each other. So, and Fruchtem and Reingold, which is another often used algorithm, tends to place nodes further apart if they are disconnected from each other. So Fruchtem and Reingold tries to capture exclusivity and cohesion, but across groups, whereas Kamarikawai typically shows you this sort of core periphery kind of structure. It's better for revealing core periphery structures. So, excuse me. So this is lending ties in Renaissance Florence, and we use these data to actually find that network lending ties in this context had two very different connotations. One, it was used by these, by the business elite, the nodes in red, to consolidate their financial positions by lending money to others like themselves for business purposes. But the vast majority of the blue nodes are not the business elite. And they were basically lent money, or they were involved in these money lending kinds of ties for kinship obligations. Literally, I can't meet my tax obligations, so somebody lend me some money. And the way we came to this conclusion is by looking at those narratives that came along with tax documents, but also by doing a lot of in-depth analysis of the cultural context, of who each of these nodes were, what their attributes were, that is, what families they belonged to, were they Medicis, were they allies of the Medicis, and so on, but also a whole bunch of other network information, their involvement in political networks, in marital ties, in neighborhood networks, and so on. And we put all of that information together to come to this conclusion. So more generally, networks can be used for a variety of different kinds of questions. Typically, positionality is something that helps us figure out outcomes, certain kinds of behaviors. And by positionality, often we're talking about positions of influence and power. So certainly the red nodes in the middle were in occupied positions of power in that network. Distances between nodes, as we've come to know more recently in the last few years, helps us figure out the spread of behavior like diseases. And the whole point of social distancing and exclusion was to be able to enlarge these distances between people during COVID, to prevent or to break networks, or to break the ties between people so that the spread of COVID could be stemmed. Other kinds of questions, which I'm not going to be able to get into, but I'm going to leave this here so that if you want to come back to it, you can. Okay, so I promised that I would come back to this question of how to find social networks. So in some cases, networks are evident. So when I think of international trade, that lends itself to being rendered as a social network and lends itself to network methodologies. However, there are a variety of different things that don't necessarily look like networks. For instance, I'm doing a project right now with a graduate student where we're looking at relationships between academic institutions and the companies that recruit from those academic institutions, and we're treating it as a network to see if recruitment practices help to consolidate status inequalities in academia. And sure enough, we find that elite schools tend to partner with elite companies and vice versa, right? So that problem has previously only generally been analyzed using ethnographic techniques and standard statistical approaches, but we're treating it as a network. And I sort of have this challenge in my graduate classrooms often, which is, think of a problem, any kind of problem that you're interested in investigating, and let's see it as a social network. Let's see it as a network problem. Let's try to cast it as a network problem. How might we use network approaches to solve that problem? And if you can get yourself to think that any social situation can be cast as a social network, not any, that's an extreme idea, but most, then you can see yourself, you can call yourself a network analyst. Okay, so I have about 4 or 5 minutes. I'm going to get into measurement for the last 5 minutes. Now, network measurement can get pretty complex. And the reason is, even if you have 50 nodes, you know, if you have an N of 50, you can't do any statistical analysis on it. But if you have 50 nodes, the ties connecting those nodes can make many, many, many different kinds of variables. Here's an example of what's called a triad census. These are 16 different ways in which 3 people can be connected to each other or not be connected to each other at all. Now, if you notice that the arrows here are directed, that distinguishes between a directed tie versus a non-directed tie. A directed tie is one where there is a sender and a receiver. If I lend you money, there is a direction to that relationship. But friendship, generally, we don't think of as a directed tie, certainly not siblinghood. We don't think of siblinghood as a directed tie. If you're my sibling, I'm your sibling. There's no directionality to it. Other often used measures are forms of centrality. Centrality typically is an indicator of a position of power in social networks. We can think of it in terms of who's more popular, who tends to lie in between other people. People who tend to lie in between others tend to have can leverage positions of brokerage. A third kind of centrality is one of closeness. Who tends to be more close to everyone else? And that person can be critical if dissemination of information is important. There are other kinds of measures that tend to often be used. How much reciprocity is in a network? That is, are networks generally of the kind where I lend you money but you don't lend me money back? Or of the kind where I lend you money and you lend me money back? Reciprocity is typically indicative of more egalitarian network, of consolidation, and of general cohesion. Ties that tend not to be reciprocated, on the other hand, are indicative of inequality. So there's lots you can do, and there are possibly 100 other measures I could list underneath here that are all measures that we could calculate from on a network that is as small as 50 nodes or as large as thousands and thousands, possibly even millions and millions of nodes. Okay, last maybe 2 slides. So the last thing I'll say is about inferential methods. Typical inferential methods, typical statistical models don't apply to social network analysis. And the reason is network data are not IID. That means that they are dependent on each other. My friends and I, if we like the same things, we can't treat our preferences as independent of each other. And this is not a statistical nuisance that you can control for by, say, using multi-level models. Because interdependence can extend to 6, 7, 8 links. Research shows, for example, that political contributions tend to be similar across 6, 7, 8 links of people away. Same thing has been shown for emotions and diseases and weight, for example. This is a very well-known finding. So what do? Instead, what we do is we use simulations. Okay, so what we do is effectively, since we don't know the distribution of our attributes that we'd like to measure, we use simulations instead. So let's say we have 2 kinds of relationships measured on a set of actors, advice and friendship. And we want to test if those 2 tend to go together. That is, does advice tend to be layered over friendship, or do those 2 tend to be orthogonal kinds of relationships? We can't run a simple correlation analysis because that assumes that friendship ties and advice ties are generated independent of each other. And that is not true. So instead, what we're going to do is we're going to use this simulation technique. And this is a very simple simulation technique for quadratic assignment. Sorry, I didn't say QAP stands for quadratic assignment procedure or process. It's a very simple procedure whereby you take one of the matrices and you permute its rows over and over and over and over and over again. And you generate a distribution of these simulations. Each time you permute the matrix, you calculate the correlation coefficient between friendship and the permuted matrix. And essentially, you generate a distribution of correlations. And then you situate the empirical correlation on that distribution of correlation and run standard hypothesis tests. Now, this is an extremely simple simulation. This is a very simple strategy. As the methodology, as your asks get higher, the methodology, the simulation strategies become more and more complicated. But ultimately, inference in social network analysis relies on simulation-based techniques. And I'll stop there. And I think simulation will make for a good segue to your talk. Oh.
Questions? Well, by the way, we try and keep questions until the end because we're recording these, and it makes better sense. I think if we compact them all at the end. Questions?
Yes.
When you say, hang on.
When you do inferential methods, are you usually trying to predict something like where an edge is, or might you try to predict like where a certain structure exists in the network?
Yeah, so typically inferential techniques in social networks can be used for both kinds of things. So where might an edge appear? So that's longitudinal kinds of models. Exponential random graph models, which are used for static kinds of data, are used to find links between micro-level structures and macro-level structures. So is this empirical macro-level structure where we might observe, for example, a core periphery structure, is this the result of micro-level stars? Is this the result of micro-level triangulation? Is it the result of homophily or these kinds of things? So it's one way to link micro and macro, but it's also ways to test sort of as hypotheses. So is this a network where there is homophily by gender after we control for homophily by race? So we can certainly test these kinds of hypotheses using inferential techniques.
Thank you for your presentation. I was wondering, for someone who is interested in learning social network analysis, what are some of the resources you would recommend for like entry level? Is it a book or are there websites? What are some of the best ways to get hands-on?
The reason it's hard, so when I was thinking about this talk, I wanted to get deep into the methods, but it's very hard to get deep into the methods without switching your way of thinking to thinking relationally. So ideally, I would say to anybody who's interested seriously, to students who are seriously interested in taking social network analysis, or somebody who is interested in dabbling in social network analysis, even if you're done with your PhD, for students, the ideal pathway is to take courses. I would say if you have a course, if you find a graduate course in social network analysis or network analysis even, that's the ideal way to do it. And once you've sort of taken a course once, thereafter it's the standard way. Yes, there are many, many books on social network analysis. There are many online courses that are available and plenty of resources that are online. But I think the initial foray, especially for students, would be my personal experience and my general advice to graduate students is to take a course. For people who are done with their PhD, it's too bad you can't take courses anymore. I wish I could take lots of different courses. I would say the ideal approach is to start with books, not with books that are methodologically focused exclusively, but general books that introduce you to the ideas of social network analysis, to the theory of social network analysis, which then helps you think appropriately about what techniques are useful.
With what you were saying before about like microstructure creating macrostructure, how similar is that to how in other fields they might ask a question like, what is like the decision rule that say a bird uses and that causes all of the birds to fly in a V? Okay, so birds of feather flock together. Is that what you're thinking of? I mean more like there might be like a very simple organism like an ant might use a very simple decision algorithm that causes it to follow some like complex behavior, or birds tend to fly in a V. These might be due to very simple rules distributed across many. So the classic example of this in the context of social network analysis is what's called preferential attachment. Preferential attachment is the idea that I want to make connections to people who are popular, well-known, influential. At the micro level, that benefits me because I'm probably going to get more access to resources by doing that. And then what that does is it sets into motion a sort of self-propelling effect where if I attach myself to somebody who's marginally popular, that might impel a few other people to attach themselves to this person who's slightly marginally popular, but then that sets into motion the individual's popularity and more and more and more people connect to them, and that makes them sort of an influential star. We literally use the term star, a star in the network. At the macro level, that has implications. So this very micro preference, my need to, or my desire to elevate my own status by connecting with somebody who's even slightly popular, creates this self-fulfilling mechanism or reproducing mechanism which reproduces inequality over time and consolidates it, but also at the macro level, it creates effects
whereby some people become extremely powerful in the network, and then that has implications for the distribution of resources, dissemination of information, and so on.